Hello, this is Dr. Terry Villarreal. I'm walking you through on how to do Introduction to Molecule Drawing in your Mastering Chemistry. So, drawing molecules is just an extension of Lewis diagrams. Essentially, when you think about chemistry, especially for you guys, you're going into nursing, a lot of things that we deal with when we draw them, when we look at these molecules on paper, they're in a 2D environment, but you, your body, everything that we have that interacts is in a 3D environment. So we've got to understand what these molecules actually look like. And Lewis diagrams allow us a way to see the connectivity. But now what we want to do then is to be able to take these basic ideas and to draw them. So what they want us to draw here is sodium formate. So sodium formate is right here. It's a carbon, it's connected to an oxygen, hydrogen, got double bond here, got a sodium there. So it's saying draw a sodium formate by placing atoms on the grid and connecting them with bonds. Okay, so we're going to come down here and we're going to clip them to the bottom and we are going to click here. It says carbon. We're going to click carbon right there. Right now we've got a carbon. Now we're going to change this right here. Right. So we're going to draw a bond between them. Right. We have a double bond like that. And now though, we want to change that top one because if you look right here, this we want to change to an oxygen, and I'm going to undo that because it looks like that got stuck. Let's erase that. Okay, let's try that again. So we're going to click right here, and we are going to actually delete that. So we're going to come back down. We're going to pick carbon, and so we are going to draw a bond like this, carbon-carbon, and this way. And so these are not the right atoms, but that's okay right now because we just want to draw them. So I'll just click this. Now, if you look, I have that carbon with 3 carbons coming off of it, but now I'm going to change it to an oxygen, and a hydrogen. So I'm going to come down here and I'm going to click on hydrogen. And I'm going to unclick the bond, and then I'm just going to click that. So now that's going to replace that one. I'm going to click this double bond here and click that to change that to a double bond. And then I'm going to come down to the oxygen and do the same thing here and here, right? So you want to make sure that you have these bonds off when you're changing the atoms. Otherwise, it'll just add a double bond to that atom, right? Like you saw it happen when I did it. So this is what you should do now. Now what we want to do is add lone pairs. So if we go back up, that's lone pairs there, the 2 little electrons. So those 2 little dots are. You see the oxygen at top has 2. So we're going to click 1, 2. The one on the right here has 3 lone pairs. So I'm going to come down here and go 1, 2, 3. And now we got to make sure we put our charge. So we're going to take this and we're going to click on that oxygen, that negative charge. Oh, sorry, that was I'm going to undo that. That was not the charge. The charge is down here on the left side. My apologies. Now we're going to click this atom and click that negative. So there we go. Now all we need to do is just add our sodium atom. So we're going to put Na right here. Nope, that's nitrogen. Sorry. Come down, and so carbon, hydrogen, oxygen, nitrogen, sulfur, phosphorus, fluorine, bromine, chlorine, iodine, and then just general, but we want more. So we are going to come to the periodic table. Sodium, all the way right here to this third group. It's in our first group in our 3rd period. So sodium right here, we click sodium. We click close, and then we're just going to click right here in the middle. Now we're going to go back and look and say sodium. Does that have a plus charge? It does. So we're going to click plus here, and we're going to click plus there, right? So now that has everything we need. So then we're going to hit submit, and hopefully that worked well. Yay, that worked. So now we know that that works just fine. Okay. So you saw some of the errors I can make doing that as I have a drink of my fruit punch. I'll let you guys know I'm currently in Virginia, so I'm a few hours ahead. So now we're going to do overview organic. So organic's a little bit differently. When we think about organic, that's the chemistry of carbon, which is what makes up a good number of the things in your body, such as carbohydrates, your sugars, which is what carbohydrates are. You have your fatty acids, your lipids, DNA and RNA, proteins, enzymes. Carbon's the central backbone of all of these molecules. So understanding how this works. So if you see here in this picture, we have this huge structure. So here's one of the things you need to keep in mind. Wherever you have something where lines come together right here, that's a carbon. Or when you see 2 lines come together at a point, that's a carbon. So carbon 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 carbons in here. Then you have nitrogens, sulfur, and it looks like 3 oxygens. All right, so now it says it wants you to draw the molecules on the canvas by choosing the button. So it wants us to draw this thing. So what we can do is that thankfully when we do some of these things is that we can draw some of these rings very easily. So we're going to draw a ring, because if we go back up here, there's a ring there at the bottom, there's a ring there at the top, and now we're going to come to this bond. And if you look, we have a 5-membered ring pointing up and a 5-membered ring pointing down. So we're just going to click at the bottom of that like this. So I'm going to click that. There we go. All right. So now we have 1, 2, 3, 4, 5 carbons coming off. So we can come here to this little dealie. And then we're going to go 1, 2, 3, 4, 5, right? Like that. So that's the 1, 2, 3, 4, 5 carbons coming off. But now, let me just double check to make sure that that was right. Yep, so then we're gonna have a oxygen this way and a double oxygen that way. So now this is going to be a double bond, and what we're gonna do is we're gonna change this to an O and this to an O. So we come back up here and double check and say, yep, that's there. So if you notice here, the angles are slightly off. That's fine as long as you have the right number of carbons there. That's going to be fine. So now I have a sulfur at the bottom part of my ring here. So I'll click the sulfur and come down here and click that. And then I'm going to come back up and say, all right, nitrogens are in those top 2 left corners. So I'm going to come up here and here. And now I have a double bond coming up like this, except that's going to be, just double check, that should be an oxygen coming off of that. Yep, it's oxygen at top. So then I click that oxygen, and now that should be correct. So let's go ahead and click submit and make sure that this works. All right, that's good. That's good. So now we're going to come down here, and now we have what we call geometry, 3D geometry. So like I said, in your body, you think about enzymes have shapes for molecules to interact with them. And in order to understand that, you've got to understand the 3D geometry. Like, this is how proteins are effective, is that things go into the pockets. And if the pockets are the right shape, like, you know, imagine that this is my substrate, it comes in, and if it can fit, enzyme can do its job. But if the shape is wrong, you know, then the object can't enter, enzyme can't do its job. So this is why we really care about the actual 3D shape. And so if you look here on these 2 molecules, this solid black line means that it's coming out of the page towards you. The dash means that it's going into the page. And if it's just this irregular line like this, that means that it's just on the plane of the paper. So the bonds that have those just regular lines, those are within the plane of the paper, that's flat. But this chlorine here that's coming off is coming out of the page, and that hydrogen here is going into the page. So now it wants us to draw this again. So let's go ahead, and it says go ahead and draw either one. And it looks like this might be a radical right here. We got a negative charge here. So we've got a lot going on here. So let's go and just take a look here. So let's go and go. We have 1, 2, 3, 4, 5 carbons in a row. So we're going to come back down to our little chain thing. And so we're going to go 1, 2, 3, 4, 5, like that. All right. So now that we've drawn our 5 carbons, let's go ahead and go back up. So now we have a double bonded oxygen coming off like this way. And then we have that O minus there. So we're going to change this right here to an oxygen and an oxygen. So now let's go ahead and take a look. That oxygen has a negative charge. So we are going to hit this negative charge, which is, if I find it right here, negative charge right here, we're going to click on that. There we go. So that's got that negative charge, removes that hydrogen for us automatically. And so it looks like we have a radical. Oh, we also have a carbon coming up right up here. So I'm going to do that there. And now it looks like there's a radical. You can kind of see, I'll go back up. See this little dot right here? That's what we call a radical. It's just 1 electron. Electrons are normally paired. They like to be paired. Radicals are very bad for you. Just for a little information, have you ever heard of, like, if you get anything in your diet, like it's a free radical fighter or stuff like that? Your body is constantly producing radicals due to radiation from the sun. Oxygen is bad for you, technically. If any of you drink or smoke, do any type of like illegal substances, I'll leave it at that. Even drinking and smoking produce these free radicals, and they damage your skin and your organs over time. So what helps to get rid of them? Water. Water is what's going to flush them out, but really what helps get rid of them, your leafy vegetables, your green, your blues, your red, like fruits and berries and stuff. What makes those, you know, fruits and veggies so colorful, those dyes, right? Those actual compounds, those soak up the radicals and they just help get rid of them. So like when you hear people say like, oh, it's going to cleanse your body, don't listen to them. All you need to do is make sure that you're taking care of yourself by drinking plenty of water, eating plenty of fresh fruits and veggies, and that'll take care of all that stuff. Your liver is a remarkable filter. So if you are drinking plenty of water, eating your fruits and veggies, you know, you're going to be okay. And if you limit how much exposure you have to sunlight without sunscreen and you don't drink or smoke and other things, you'll limit that. And so that's why usually people who eat a very rich diet in fruits and veggies, don't drink and smoke and avoid sunlight, drink lots of water, they look fantastic because their body is not under so much free radical assault. That's the side note. But now I put this free radical here. We're all good. Now it looks like we've got the right side down. All we need to do now is that we need to come back and put in the chlorine and the hydrogen. So what we're going to do is you come back down, we click on this bond thing. And so now we see this wedge. So we're going to draw the wedge like this. And then that's what that's called, the solid one. Then we're going to pick what the dash is called. And we're going to come down here and go like that. And so then all we're going to do now is that dash should be a hydrogen. So I'll click a hydrogen and change that to a hydrogen. And then this one here should be a chlorine, and that should be good. So let's make sure that this is correct. I'm going to hit submit. All right, it worked. And part D, finally, it says review the videos and then identify bromine atoms in the molecules shown, such as mapped in blue with a 1, used to hint to learn more about mapping. Okay, so it says that we need to map this. And so if I come into here, I think that this is going to be add a map. And so we're just going to click on our bromine, 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 like that. And that should be it. Click submit. There you go. And that's all you need to do for that. Hopefully that helps. I'm going to post this link to the LMS. So hopefully that'll work. Good luck to all of you. Please let me know if you want any more of these videos for any of these questions, and I will gladly upload them. Have a wonderful day.